Hi and welcome back. Um, in this video, we're going to take a look at how to invert binary tree. So, interviewer could ask us, so construct a function that accepts a root element. So, in this example, we would get node 4, and this function needs to just invert this binary tree, or one variant could also be invert binary search tree, which is basically the same, right? Right. So if you look at our result, so this would be our result when inverting a binary tree. We can look that it's exactly like it would be like a mirror, right? So 4 is here, 5 here, and 6 is here, right? So first time you encounter this problem, it would probably seems quite intimidating, right? So how would we just track everything down and construct a new inverted binary search tree? But actually, using recursion, we will see that it's quite elegant solution. Like let's see. What we basically need to do is start with root, and on each node we just swap left and right. So this would look like this. Okay, cool. So we're swapping 3 with 5, and here we're swapping 3, right? So what happens here is that once we do the swapping, also its children, right? Because the let's say that 3 and 5 hold its children. When we do swapping, this also gets moved. So these two children nodes are in the correct position, and we can just recurse to the left and recurse to the right and do the swapping until we hit the node of none, right? In this base case, we just return, right? Cool. So let's talk about time space complexity for this one. So for time, we would say that it's of n. We're visiting every node here, and for space, it's of d. So d is the depth of a tree, right? Cool. So let's look at how this would look in code. We need to, so we will have a function called invert, which will accept root element. So let's create this root. Just now, let's say it's 3. The left child can be 1. Right child it's actually 4. 2, 1, and then 3, and then the 3 has left child of none and right child of 4, right? And now we need to construct a class node. Of course, we need the constructor, which is the self value left with the default value of none, right? Also has default value of none. Right, so we just constructed a class node that enables us to generate our tree. The root is 2, like in this example. Left child is 1, we see here, and 3, 4. This looks, oh, this is none. Cool. Right, now we can actually invert the root. Do this. Yeah, let's do it. Def invert. And as we say, because this is a recursive function, we need to take care of base case, which is whenever this root or node is none, right? We need to just return if not node, which means node is none, we just return. If not, we need to swap left and right nodes, which in Python we can do in one line. So node.left, node.right, node.right, node.left, like this. Like this, right? In other languages, if you don't have this one-liner, you just create temporary variable, let's say for node.left, right? Now we can override this node.left, node.left equals to node.right, right? Node.right equals to temp, right? So yeah, but in Python we can do it in one line. Other languages you probably need something like this, right? Cool. And return node. Cool. So of course, yeah, we forgot something. So once we're done with swapping, we of course needs to invert. We need to call recursively node.left and of course node.right, right? Okay, so basically our inversion of binary tree is done. Now all we need to do is just print the values to the screen so we know that our solution is correct. So let's create a traverse function. So this accepts a node. If not node, return, print. Now because now this is a pre-order traversal, right? Because we're printing and then traversing. Now this would be in order traversal if the printing is between and post order, right? So this is about our traverse function, and now let's do it like this: traverse root, like this. And then we can traverse inverted like this. So what do we expect here? So the first time we traverse the initial binary tree, we will print out 2 and then 1, 3 and 4. So 3, 1 and okay, cool. So let's clear the output and run the code. So 3, 1, 3, 4. So 3, 1, 3, 4. So this is correct, the first one, and the second one, the inverted one. So it's 2, 3, 4, 1. So it's 2, and because it's inverted, it's here, 3, 4, 1. Yeah, it's correct. Cool. So to recap, when we invert a binary search tree, if we do it recursively, we handle the base case. After that, we do the swap, swapping left and right node, and just recurse to the left, recurse to the right, and we're done. That's it for this one, and see you guys next time. Bye!